Hey guys, this is 4.3/4 notes. Notes together because they're very similar in what they go through. So um, that's why I put them together. So to start off, before we get into triangle congruence, proving them, we need to go over certain terms like something like an included angle. So this is an angle between two sides of a triangle. So right, an included angle could be here, here, or here. So like it's inside a triangle, right? It's an included angle. So right between this side and this side, right? In between those two sides is called an included angle. All right. So now we're going to go through three types of theorems that allow us to prove that we have congruent triangles. Okay. So the first one is called side angle side. And SAS is how we abbreviate it. You'll see SAS, SSS, rather than side angle side. Okay. But when you think of SAS, just think of side angle side. It says if two sides and the included angle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so if we have two sides and then an included angle, which we just went over, is the angle between two sides, right? If the two sides of that included angle are congruent to another triangle's two sides of that included angle, and the included angle is congruent, then they're congruent by side angle side. So you should have a dash, an arc, and a dash, right? You read it side angle side. Side angle side. Okay, so whenever you see two triangles, right, their angles are congruent, and then the two sides, right, that make that included angle are congruent to the other two sides of the other triangle, then we can prove it by SAS. Now, side, 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 right? If you think about it, right, if three sides of one triangle are congruent to three sides of another triangle, then the two angles are congruent. Okay, so sorry, two triangles are congruent, not two angles. All right, so if you have three dashes, right, 1, 2, 3, 1, 2, 3 on two sets of triangles, that means every side is the same length to its corresponding side. Therefore, it is congruent, right? So, right, this one would be triangle RST is congruent to triangle XYZ, right? And that's by SAS. This one, right, triangle ABC is congruent to triangle DEF by side, side, side. And then the last one is called corresponding parts of congruent triangles are congruent. So, right, if we are told these are congruent triangles, right, ABC and XYZ, then every single corresponding side is congruent to each other and every single corresponding angle. So, right, A, and you can read it how it's written. A matches up with X. Okay, so A and X match up. B matches up with Y. So that's the two arcs. And then lastly, C matches with Z. And same thing about the sides of them, right? AB and XY. AB, XY. BC, YZ. So how it's written, the order it's written is the corresponding side and corresponding angle to it. And lastly is AC and XZ. Right, so we can write it, we said angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. And then we said the sides, right? So AB is congruent to XY. BC is congruent to YZ. And AC is congruent to XZ. So let's start applying this to examples. So it says identify which pairs of triangles are congruent by SAS. Well, right, or by SSS, or neither. Right. So if we look at the first one, right, we have 3 sets that are congruent. All right. So all 3 sides are congruent to each other. So this is triangles congruent by side, side, side. Okay. All right. The next one. Well, now, one thing, right? Shared sides are congruent. So you can see that these triangles are touching each other right here. So this is a congruent side to each other, right? Of that triangle. So that counts as a congruent side. But we cannot mark anything else, right? We don't know about the angles. We don't know about these angles. We don't know about any of the other sides. So this one, we need more information. And then the last one, again, mark your shared side. There's already a 1- ones. So we're going to put 2 dashes on this shared side. And now read it. Side, angle, side, side, angle, side. So if they're both side, angle, side, right, that means the triangles are congruent by side, angle, side. All right, this next one. So you might see on the paper there's like a T-chart proof, but we're going to skip over that. We're going to go right to this example 1, where it says in the following figure, QR is 12, RS is 23, QS is 24, and RT is 12. Okay, so RT is 12 and QR is 12. So we know these are congruent to each other. We're also given RS is 23 and RV is 23. So these are congruent to each other. And then last one, QS is 24, which is congruent to TV, which is also 24. Okay. So, all right. Now we can also mark, since we know, right, we know these triangles are congruent. So triangle QRS is congruent to triangle TRV. Right, and you can read them by, right, the 1- first goes, then the 2-, so TRV, right, QRS. All right, so those are congruent. Now we can also label each angle congruent too, right? Because we know they're congruent, that means by the congruent, the corresponding congruent angles and sides, right? The angles have to be congruent, so T and Q are congruent. This QRS and TRV are congruent, and then V and S, right? The one on R, since 2 angles share R, we cannot label it just as angle R. It has to be QRS and TRV. So we can label the angles. Right? Angle T is congruent to angle Q. Angle TRV is congruent to angle QRS. And angle V is congruent to angle S. Right? It doesn't matter which order. If you wrote S to V, it doesn't really matter. The only thing that matters is the order of the 3 one's the TRV. That R has to be in the middle of both. And then we can also write their sides, right? RT is congruent to RQ, or TR is congruent to QR, it doesn't really matter. Then RV is congruent to RS. And lastly, TV is congruent to QS. Maybe I'll just rewrite the first one just so it matches the lettering up top. Right, so QR, RT is congruent to QR. RS and RV, and TV and QS. And that's it. All right, so this one says state what additional information is required in order to know that the triangles are congruent for the reason given. We're looking for side. So we need to mark 3 sides. So this is a shared side, so we can mark that. That counts as it. The only thing that we need to mark, I'll put in blue, is these have to be congruent to say that the triangles are congruent. So we need DX congruent to YZ. Right, that's what we need. And then the next one, right, we're given RS is congruent to XY, and then YZ is congruent to ST. We need that RT is congruent to XZ in order to prove that this is these are congruent triangles by side. Okay, so you're just looking for that missing piece, right? We know side needs all 3 sides congruent. We only had 2 marked in the first one. We need to figure out the third one. Same with the next question. We had 2 marked. We needed to figure out the 1' one. Next one, we're looking for side angle side. So we know it shares this side, so we don't need to add that. But what we're missing in side angle side, we have the 2 sides. We need the included angles congruent to each other. So we need angle EFG congruent to QFG. Angle QFG. Right, we need that for side angle side. Right, this was for SSS. All right, and then let's look at the last one. We're given a side. Now, these angles you need to remember back. Those we know are congruent because of they're vertical angles. So we don't need to add that. That's already given. They're vertical angles, so they're congruent. The piece we're missing is the other side, right? If this is the included angle, this has to be the other side right here, and same right here. So what we need is DS congruent to TS, right, for side angle side. All right, now we'll move on to the part of 4.4 of this, which is these 2 theorems that we'll focus on. So we have this warm-up here that goes through finding the indicated side length and angle measures. So if we look at it, we want to find X and Y, right, for the first one, right here. So how do we find that? Well, this is isosceles. No, not isosceles. Sorry. This has this side. You go with this side. Right, so and this side is congruent. So these triangles are congruent, right? So that means their sides are going to be congruent, right? The corresponding sides. So 50 is congruent with here because it's between the 1 dash and 2 dash. The ones between the 1 dash and 3 dash are x and 74, right? And then y in this angle are congruent, okay? So, right, x is 74 degrees, right? We can tell because x and 74 are congruent to each other. Now to find y, right, y is congruent to this one. So if this is 74 degrees, right, this is also y degrees. So 50 plus 74 plus y equals 180. So y is equal to 54, right? If you subtract 74 and 50 from 180, you get 54 degrees. Next one, right? We have they are congruent by side angle side, right? So this is also z. Now the right, that means corresponding sides are congruent, right? So 15 and x, right? So x equals 15, right? Because it's congruent to side 15, right? Y is congruent between the 2 dash and 3 dash, so 50. So y equals 50 degrees, right? And then z plus 13 plus 50 degrees equals 180. So z is equal to 117 degrees. Okay, so those were kind of just warm-ups using the facts from the 4.3. Now, in the included side, right? So we went over included angles. Now we're going to go through included sides. So included side is the common side of two angles. So if we have a triangle here, right? And say we have an angle here and an angle here. The common side is the side in between them. In between two angles. Okay, so in between those two marked angles would be the common side. Okay, that's going to be used in angle side angle and angle side. Okay. So now we have listed other terms: angle side angle or ASA and angle side angle AAS. Okay. So angle side angle says if two angles and an included side are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So we can prove if there's an angle, then a side, then an angle. Also, if two angles in a non-included side, right? So two angles, then a non-included side are congruent to two angles in a non-included side of another triangle, then the two triangles are congruent. All right, so if we look at this, the angle side angle, you've seen angle, then an included side, then an angle. So included. Okay. That proves that the triangle LMN is congruent to triangle RST. And then the next one, see how we have an angle, another angle, and then a non-included side. So a side not in between them. So angle, angle, not included side. Okay, so either of the non-included sides would make it angle, angle side. Okay, so triangle was a WUV is congruent to triangle ZXY. It doesn't really matter the order as long as they match up, right? You can see W and Z match up, right? So we could label it however we want as long as the corresponding angles match up. get into an example. Right. Identify whether we have side, angle, side, 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 angle, side, angle, or angle, angle, side, or neither. Okay. So, right, always mark the sides that are touching. Right, touching sides are included. So this one we have 3 sides. So this is by side, 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 side. Right. This next one we have an angle included side, and then another angle. We also have an angle included side, and then this is a vertical angle, so it counts as well, right? So this one is angle side angle, because read it, angle side angle, angle side angle. The next one, we have an included side here, but we only have an included side in an angle. We don't know anything else. We only know 2 things. So for this one, right, we cannot determine it. There's none, right, that concludes that one without adding more. The last one, right, we have a shared side here. So it goes side, angle, side, side, angle, side. So side, angle, side proves this one. All right, let's look at this kind of real world problem. It says a technician installs cables from a cell phone tower to the ground. To pass inspection, both cables must meet the same length. So, right, if we want, we can kind of pull out this triangle. Right, we have the tower going through, and we are told the cables are the same length, right? Cables, same length. We also are given that these are both 52 degrees. Now, to pass inspection, both, and then does this meet the cable length requirements? Well, right, we know that this is a shared side, the tower, right? So these triangles are congruent by side, and then included angle, then a side, right? So side, angle, side, right? And, right, we need to see if all the sides are equal, right? And if we know that the triangles are congruent, then by the CPCTC, right, corresponding parts of right, are all going to be congruent. So that means that these sides are also congruent. So, right, it does, the cables of the triangle must all be the same length. So the cables of each triangle are the same length. All right. Now we're gonna kind of go through like in 4.3 where we're stating if the following shapes are congruent by ASA, and then the next one is figuring out what additional information we need to add to prove by ASA. All right. So this one, right, we have the included side here, so we have an angle side angle. So, right, yes, this is congruent by ASA. The next one, we have 2 sides, and that's it. So no. Right. The next one, we have a shared side, and then we have an angle side angle, angle side angle. So yes, this is congruent by angle side angle. The next ones, we're finding the additional information. We're given the right triangles are congruent. We're also given these are vertical angles, so they are congruent. Right. So actually, let me put those in red so they kind of count. Right. And then what we need to add to make this angle side angle is an included side. So the ones in between those 2 angles, so CS and RS, right? So CS needs to be congruent to RS. So this is the information we need for ASA. The next one, Again, we have vertical angles. We need to add the included sides. So WV and KV. So WV needs to be congruent to KV. We don't know that, but we know we need that for angle side angle. And now we'll do the same for the next one, angle side. Right, so this one's angle side. So we'll state if we have them. This first part, right, if we look at it, this is congruent by angle, right? We don't have a certain thing that, like, we can tell by corresponding parts, but not by angle side. So no. This next one, right? We add the vertical angle, and we have an angle side, right? It's a non-included side, so angle side, right? It's not in between, so yes, this is by angle side. Add the vertical angles, angle side, angle side. Sorry, this should be 2 dots. So yes, angle side. You just make sure if you're doing angle side, the side is not in between the two angles, which this one is not. All right. Now we're going to state information we need to add. So the given information on this first one is that line DC, right? We know they're touching, so that's a given. Then we know we cannot add the angle C's, right? Because that would make it angle side angle, right? But we can add that angle E is congruent to angle T, right? That would make that line DC not included. So we need angle E is congruent to angle T for angle side. All right. Just remember, you can't add that ECD or TCD. The next one, we cannot add the two sides LM and XY because they're included, but we can actually add two different ones, right? So we need either the NL is congruent to ZX, right? So that side would make it angle side, or the other side, right, that's not included, which is YZ and MN, right? So either one of those would make it angle side angle, right? So you could add either one of those and be angle side angle and prove that they're congruent triangles.